Welcome to Melanie's Mystery Numbers Learning Aid tutorial. The heart of Melanie's Mystery Numbers is the interactive facility for students to practice problems that help learning basic numeric concepts. The main menu offers a progressive challenge by increasing the number of digits from 2 to 3 and then 4, which offers increasing complexity of relationships amongst the digits and consequently more challenging clue analysis at succeeding levels. The second group of 3 levels of questions incorporates the use of decimals. Upon choosing a level, a question is randomly generated and the first clue is presented. The student may determine the answer from one clue or request a second and then a third. It is sometimes possible to answer the question with only one clue and sometimes with 2 clues, and it is always possible to determine the answer after 3 clues. We'll give it a shot here. We want an even number here and a prime number here, and we'll see what we get. Whoops, we're incorrect. So the program responds with an appropriate congratulatory message or an indication that the answer is incorrect, offering the student an opportunity to resubmit. So what we're going to do is click this off here and take a look at our toolbox, see what help we can get. And as you can see here, there's 3 different components that all relate to the clues that are provided. And there's enough information here either in the arithmetic matrices to help them calculate, or the glossary of terms that are used in the clues, or the characteristics of the single digits that are indicated in the clues. So we'll give it another try here. The 1's digit is prime, as it shows underneath. The 10's digit is even. And the 1's digit is 3 more than the 10's digit. Well, we'll make this a 5, which is prime. We'll make this a 2, which is even. That should give us the right answer. There you go. Then when we get the answer, the student is told how effective their answer was in comparison to what they've done previously at this level, and in this case we got the 15th fastest time, and it also gives an indication how well they've done relative to others in this particular category. A clock is initiated, of course, at the time the problem is initiated, and of course it terminates when the answer is provided. And this whole process of the clock and the relative performance is a significant motivator for practice in this format. Teachers may access the student performance information through several reports that may be generated by day or for a specific period. Let's do a more detailed walkthrough. The first order of business is to log in. Here we enter the student's code, and it then lists any multiple classes, and you have to choose the appropriate class if he's in more than one. In this case, there's only the one. To initiate generation of a problem, a mystery level is selected. We're going to take 3-digit. A question is then randomly generated, and the first clue is displayed. And the student may attempt to determine the answer or request another clue. In this case, it says the 10's digit is a placeholder. We happen to know that the only digit that's a placeholder, considered a placeholder, is 0. So we can put that in right away. Notice that with our second clue, there is a letter that displays underneath the corresponding box. And if you look at the legend below, you'll notice that these are short forms or codes for attributes that help you to keep track of which digits are which, represent which types of attributes for a digit. And that can be helpful in a visual aid in determining the answer. The answer box itself can be used, for example, if you want to just guess, well, it's a prime number, let's put 3 in, that's a prime number, can be used as a work box. But the student may also, of course, want to be using hard copy notes to help him with his determination. Now, we'll just select the last clue here, and in this case, of course, as you can see, we cannot determine this answer until we put the third clue in, because it includes important information about the relative aspects of the different clues. Now, if we put in an answer here, chances are, because we really didn't think about it, it's going to be incorrect. And that's what happens when you put in an incorrect answer. You get the appropriate message. So let's say the student would like to have a little bit of help with this question, and he goes to his toolbox. And in the toolbox, of course, what there are is tools to help with the three basic aspects of what's involved in clues. First of all, the attributes of the numbers, and they're listed both by number and by attributes, so that you can see here that for the number 1, there's 4 attributes that are possible to be included in clues, and down here for odd numbers, it lists the odd numbers, or for the same thing for prime numbers, so that a student can readily go and refer to that clue and get some indication of what the category might be if he's not really familiar with those attributes. Second thing that's used in the clues, of course, is mathematical terms. And here, alphabetically, we have listed all the possible mathematical terms that could be used in the generation of the clues, so that if a student is unsure when he's reading the clue, he can go here and check to see what the meaning of that particular term is. For example, cube root, referring to the quantity that is multiplied by itself and by itself again to arrive at a cube. And an example here is 2 is the cube root of 8. So back to the main menu again, and the last thing that we have is to help the student with the actual calculation. So we have a matrix for each of the major arithmetic operations, and basically if you want 4 plus 5, you simply complete that, and you go and you get your answer in the intersection. The same principle is used for each of the other types of operations. 5 times 7 will be 35. And the same with the division matrix, except there's a little bit more answers here. They give you the remainder, the quotients remainder, the decimal answer, and the fraction. So these are all tools that help the student with his calculation. Depending on the grade level they're at, they may want to use this, or it may not be necessary. Okay, now back to the question here. We simply realize that we've run into our maximum time to guess the question, and it's given us the answer here, which was 302. So what we'll do is we'll put in a second question, and the first clue is tens digit is odd, so it puts the odd under the tens digit box. hundreds digit is a perfect square. So we want to guess at that because there's only a couple of digits that are maybe other three that are perfect squares. A 9, a 4, and a 1. So why don't we guess it as, just to use it as a workbox, we guess it as a 4. Now we look down here and the tens digit is 7 more here than the ones digit. So what we're going to guess here is that this is, the perfect square is 1. The hundreds digit is a perfect square. Sorry. This is what you got to be looking at here. Make that a 4. And the tens digit, which is odd, is 7 more than the ones digit. So why don't we make this a 9? And if it's 7 more, we'll make this a 2. And the ones digit is 9 less than the hundreds digit. Well, it's got to be a 9. And this has got to be a 0. And this is odd, and if it's 7 more, it's got to be a 7. So that's the kind of reasoning that you're going to go through. And let's keep our fingers crossed here. Ba-boom. And what it's telling us is, way to go, we got the 25th fastest time. And it happened to be my fastest time. So a lot of other folks have been doing this and done a lot better at the 3 level than I have. Anyway, that pretty well illustrates the process. So this really completes the Melanie's Mystery Numbers Learning Aid tutorial.